Welcome back. Okay, so if you're a software engineering student who, constantly stares at an exam scenario and just struggles with picking the exact right software development process model, well, you're absolutely in the right place. Consider this explainer your ultimate cheat sheet. Today, we're going to put on our senior software architect hats, right? We're building a foolproof mental framework so you can confidently ace those really tricky exam questions. Specifically, we're zooming in on a very frequent exam trap, the prototyping model, and its 4 distinct variations. Let's get into it. Okay, let's dive into this. Here's our study agenda for today. We'll hit the core model and phases first, then the 4 prototyping types, jump into the architect's decision framework, run through a practice exam simulator, and wrap up with real-world pros and cons. So, Section 1, Core Model and Phases. Let's define what we're actually building here. Imagine I'm the senior architect mentoring you on your first big project. At its most basic level, the prototype model is an approach where an initial preliminary version of a system is built, well, quickly. The whole goal here, the entire point, is to gather feedback, understand what the user actually needs, and clarify any ambiguous requirements. Now listen closely, because if you're reading an exam question and you see phrases like built quickly, gather feedback, or clarifying ambiguous requirements, those are massive green flags. They're practically screaming at you that prototyping is the right path. Now let's look at how the standard process actually flows. It goes through 5 steps: requirement gathering, prototype development, user evaluation, refinement, and final development. But here's the real secret to understanding this model. The absolute magic happens in the loop right between step 3 and step 4. You build it, the users evaluate it, you refine it based on that feedback, and then you do it all over again until the prototype actually meets their expectations. Only then do you finally move on to step 5, final development. And that specific loop gives us the 4 key pillars of prototyping. We've got iterative development, user involvement, early visualization, and risk reduction. I really want to highlight early visualization for a second. If an exam scenario mentions that stakeholders are, say, struggling to understand a concept, and they desperately need a tangible representation of the software early in the cycle, boom, that is a massive keyword. That tangible, see-it-to-believe-it representation is exactly what prototyping does best. Moving on to Section 2, the 4 prototyping types. This is all about choosing the right tool for the job. Now, what's really interesting about this slide is that this is exactly where exams get genuinely tricky. You have to be able to differentiate between 4 distinct subtypes. I want you to think of this as your architect's toolkit. We have rapid throwaway, evolutionary, incremental, and extreme prototyping. And each of these isn't just some random choice. Each one solves a very, very specific engineering problem. To pass your exam, you need to know exactly which tool to pull from the box. All right, Section 3, the architect's decision framework. Let's analyze those constraints. Okay, seriously, grab a screenshot or take some notes right now, because this is the core cheat sheet you absolutely need to memorize to eliminate wrong answers on your test. Let's break these 4 models down across different project constraints. First, if requirements are highly unclear and you need fast exploration to prevent unnecessary design faults, you're going to lean toward rapid throwaway. On the flip side, if requirements are constantly evolving and the goal is to save time compared to building from scratch every single time, well, evolutionary is your choice, because it incrementally refines an initial prototype until it's approved. Now, what if you're dealing with a complex product that can be divided into small pieces, developed individually and integrated in order to shorten delivery time? You'll want incremental. And finally, if the scenario explicitly mentions web development and fast sequential phases starting with basic HTML, extreme prototyping is your target. You can literally use these exact columns to logically eliminate incorrect options on the test. But listen, just as important as knowing when to choose prototyping is knowing when to run away from it. Your green flags for prototyping generally are unclear or evolving requirements, a heavy focus on user experience or UX, and a strict need for early user engagement. Pretty straightforward, right? However, watch out for the red flags. If a test scenario mentions an extremely tight budget where you simply cannot afford the increased cost of iteration, or, and this is a big one, if it mentions clients who have a history of mistaking mockups for final software, leading to huge scope confusion, yeah, prototyping might actually be a trap there. Let's move to Section 4, the practice exam simulator. It's time to test your new framework. Let's amp up the energy and make things a bit harder, right? We're going to test your new framework with tricky scenarios where 2 models might seem correct, but only one is truly the best. Here's scenario 1. A client wants to explore a risky idea fast to prevent design faults. Once feedback is gathered, the preliminary code will not be part of the final product. So, which model is best? Take a second to think about those key words. So the crucial point here is that the correct answer is rapid throwaway prototyping. Let's map our reasoning directly back to that decision framework we talked about. The triggers were exploring ideas quickly and preventing unnecessary design faults. But the absolute dead giveaway here, the reason it literally cannot be evolutionary, is that the developed model is explicitly discarded. It's not part of the final product. Next up, we have scenario 2, you're building a complex application. Now, to reduce complexity, the project manager wants to divide the product into small pieces, develop them individually, and then integrate them in a specific order. Which model fits this? Give it a thought. If you said incremental prototyping, you got it. The architect's reasoning here is entirely based on the structural keywords. The project is explicitly divided into small pieces that are developed individually and integrated in order. This specific model is awesome because it reduces complexity and actively shortens time to delivery. Though, keep in mind, it does come with a built-in warning. It requires incredibly careful planning to ensure all those separate pieces actually fit together properly in the end. Okay, let's look at scenario 3. Your team is building a web application. The lead engineer mandates 3 sequential phases: basic static HTML pages first, then simulating data processing, and finally implementing all the services. What model is this lead engineer describing? Do you know it? That, my friend, is a textbook definition of extreme prototyping. Literally, whenever an exam mentions web development, combined with a highly rigid structure of 3 sequential phases, and specifically starts with basic static pages in HTML format before moving to a prototype services layer, extreme prototyping is your guaranteed correct choice. For sure. It keeps the team laser-focused on product delivery. All right, moving on to scenario 4. The customer's needs are constantly evolving. Instead of starting from scratch each time, developers want a model that continuously refines an initial version, moving from V1 to V2 to V3 until the customer gives their final approval. Now, obviously this sounds like general prototyping, but I want you to think, which specific subtype is the absolute perfect fit here? If you guessed evolutionary prototyping, you nailed it. Catching this nuance is absolutely key. It's evolutionary because the initial prototype is continuously, incrementally refined based on customer feedback. As our source material highlights, doing this saves a massive amount of time and effort compared to building from scratch every single time. It just makes the whole process much more practical and honestly way less frustrating for the developers. Okay, last one. The ultimate trick question. Scenario 5. A client needs an application with a massive focus on user experience, or UX. However, they are incredibly strict on a low budget, and they actually have a documented history of mistaking mockups for the final software. Which model do you choose? Be really careful with this one. And this brilliantly illustrates our final lesson today. The correct answer here is to avoid prototyping entirely. Look for an alternative. Yes, okay, the focus on UX is a green flag, but it is completely overruled by those glaring red flags. Building and refining prototypes is super resource intensive. If they have a strict low budget, you just can't risk the increased costs. Furthermore, if they have a history of mistaking mockups for the final product, you are walking straight into the potential confusion trap that's strictly outlined in our source guidelines. Don't do it. Finally, let's jump into section 5, real-world pros and cons. Let's take this beyond the exam room. Look, knowing the test answers is great, but actually understanding why these rules exist, that's what makes you a better engineer. Take an e-commerce website as a classic real-world example. User satisfaction and ease of navigation are literally make or break here. A good team won't just build the whole site blindly. Instead, they're going to start with a prototype of the shopping cart, the product browsing, and maybe a mock checkout process. Why? Well, because if users find the checkout confusing, the team can redesign it to be more intuitive before writing all that full-scale, incredibly expensive backend code. It fosters innovation while heavily reducing the risk of requirement misunderstandings. But we absolutely must respect the final warnings of this model. You've got the increased costs from endless iterations, potential confusion about the project scope, and the risk of overdesign, which is where teams spent way too much time on elaborate details that just aren't crucial. So I'll leave you with this final, somewhat provocative thought as you go study for your exam. If a prototype is inherently just a rough draft meant to validate ideas, exactly how much time and money are you willing to waste perfecting a draft before you actually build the final product? Keep that tension in mind, good luck on your exams, and keep building smart.